In this video, we will discuss what is control valve actuator and control valve positioner. First, let's discuss what is a valve. A valve is a mechanical device which is usually installed in a pipeline. A valve has a movable part using which it controls the flow of liquid, gas or any loose materials flowing through the pipeline. Normal valves are operated using hand wheels or levers. To open or close these valves, an operator should go near to it and turn the hand wheels. In a process plant, we know that instruments should work as per the signals from the control room. For this, instead of hand wheels or levers, actuators are used to operate the valve. Actuators reduce the need of operator to go near to the valve for opening and closing. When actuators are used, valves can be operated from the control room. This type of valves, which uses actuators to automatically control the flow, is called a control valve. Any valve can be converted to a control valve simply by adding an actuator. The actuator is the major part of the control valve which operates the valve. The actuator would operate according to the signal received from the control room. There are mainly three types of actuators: pneumatic actuator, electric actuator, and hydraulic actuator. Pneumatic actuator use an air or gas signal from an external source to turn the valve. Pneumatic actuators are the most commonly used actuator for valves in the process and oil industries. In this type, the compressed air is applied either on a diaphragm or on a piston, which in turn moves the valve stem. Electric valve actuator uses an electric motor to provide torque required to operate the valve. These type of actuators are commonly used in remote locations where it will be not practical to pipe hydraulics or compressed air. Hydraulic valve actuators depends on non-compressible fluids like hydraulic oil to provide the required force to operate the valve. The hydraulic actuators can provide greater force, due to which they are used for big valves. Parts of control valve. Valve body. One of the main parts of the control valve is its body, as it is the framework that holds everything together. The ends of the valve body are designed to connect the valve to the piping by different types of end connections. The valve body may be casted in different shapes using different materials, depending upon the purpose for which the valves are used. Valve trim. The heart of the control valve is the trim. The removable and replaceable internal parts of the valve that comes in contact with the medium that flows through the valve are collectively termed as valve trim. Valve trim includes valve seat, valve disc, internal springs, etc. The valve disc is the part which allows the valve to throttle or stop flow depending on its position. The valve body and the valve seats creates a seal to stop the flow. Some control valves have one seat, while some others have multiple seats. Valve stem. The stem is connected to the actuator from one side and the other side is connected to the disc. The stem of the control valve provides movement to the disc, which results in opening or closing of the valve. Yoke. The yoke connects the valve body or bonnet with the actuating mechanism. Valve positioner. As the name indicates, control valve positioners are devices that helps in positioning the actuator of the control valve by increasing or decreasing the air pressure on the actuator. They are generally mounted on the side or top casing of the actuator. If there is no positioner, the pneumatic control signal goes directly to the actuator. As there can be other forces acting on the valve stem, the accurate positioning cannot be achieved. So, when accurate and faster control is required, a valve positioner is used. A valve positioner will have a mechanical feedback from the valve stem, which will inform the valve positioner about the exact position of the valve stem. The valve positioner compares the valve stem position with the demand generated by the controller like PLC. If the valve stem is incorrectly positioned, the positioner increases or decreases the air in the actuator until the correct valve stem position is achieved. There are mainly three types of valve positioners: pneumatic positioner, electro-pneumatic positioner, and digital positioner. Pneumatic positioner. Pneumatic positioner receives a pneumatic signal, that means air signal, typically of 3 to 15 psi from a controller like PLC. It then sends corresponding output pneumatic signal to a pneumatic valve actuator. Electro-pneumatic positioner receives an electric signal, typically 4 to 20 milliamperes or 0 to 10 VDC from a controller, and it then sends a corresponding output pneumatic signal to a pneumatic valve actuator. Electro-pneumatic positioner uses an I2P converter. A digital valve positioner receives an electric signal, typically 4 to 20 milliamperes, Hart, Profibus, etc. from a controller. It then sends a corresponding output pneumatic signal to a pneumatic valve actuator. Digital positioners are also called smart positioners. It uses sensors and microprocessors to position the valve actuator and to monitor and record data. Thus, they are very accurate.